In example 6, we want to find the exact value of the tangent of some angle minus another angle. If you prefer to use alpha and beta here, you could do that. Make sure that you make x, if x is the alpha here, then this x needs to be the alpha, and that'll be the beta. I prefer just to leave things as they are, less chance of making an error or getting confused. So let's see if we can use our formula when we have an angle difference, and we know that it's tangent. So it's going to be the tangent of alpha minus beta. So we're going to need to use the bottom symbol here. So that'll be the tangent of the first angle minus the tangent of, see that was a y, yep, of the second angle, all over 1 plus. And the tangent, when you're using this sum or difference formula, these two will always be different. And we need to put, let's see, tangent of the first angle, so that's tangent of x, times the tangent of y. Okay, so what we have now over here is some information about x and y. We know the sine of one and the cosine of the other. We actually don't have to find the actual angle itself. If we just take a look at x, we write down x, y, and r, and these x's can get confusing. These are different x's. This is the adjacent leg of some right triangle. That's an angle. So maybe I'll put angle x up here for you, and then we'll do angle y here. Alrighty, so y over r, so that would be 8 over 17, and you can use the Pythagorean theorem to verify this, but I know this as a Pythagorean triple, 8, 15, 17. For angle y then, we're going to have the cosine, so that's x over r. R is 5, and then of course that's a 3, 4, 5 triple, and you can use the Pythagorean theorem to get that or verify that if you'd like. Remember, we're going to need the tangent of x here, so this is the tangent of angle x. We always take the tangent, sine, cosine, cosecant, secant, cotangent of an angle. The inverses, that's when you're going to have the inverse of a ratio to give you an angle. So the tangent of that angle is y over x, 8 over 15. And then the tangent of angle y is going to be, and this is angle y, we need y over x. Now what we need to do is we need to take those the little expressions here, the tangent of x, out and substitute a fraction that it's equal to in. And we've got the tangent of y at 4/3. All over 1 plus 8 over 15 times 4 over 3. There we go. Alright, and so now we'll just do a little simplifying work. I need to multiply this by 5 over 5 so that I can add these two together. So it's going to be 8 minus 20, which happens to be negative 12, over the common denominator of 15. The next one is going to be 1 plus, let's see, 8 times 4, that's 32, over 45. We're going to need to add these together, and I'm going to multiply by 3 over 3 in the numerator as well. And let me scoot this up for you just a bit. And so this one's going to be negative 36 over 45 over, and then I'm going to need a common denominator here. So I'm going to make that 1 a 45 over 45, and this should be 77 over 45. Remember, when we multiply by the reciprocal, these 45s will cancel, and we'll be left with negative 36 over 77. As I look back and just check my work, the sine of angle x is y over r, or 8 over 17, so I've got that correct. And then my cosine would be 3 over 5, and so that's correct. And then I believe these ratios are correct as well. Y over x, 8 over 15, and then y over x, 4 over 3 here. Good to go. Plug and chug here, do a little substitution, and then make sure to be able to take care of that by hand. So negative 36 over 77 is the correct answer.